Hello, Internet. So nice to see you this fine Tuesday evening. Happy Tuesday. Welcome to Everyone Loves Math Live. So, I'm Joey. I'm your mathematician for the evening. I'm also the founder of Everyone Loves Math Live. Hey, what is Everyone Loves Math? Well, I'm glad you asked. I know I've done this the last couple live streams, but you know what? We got to spread the word, man. So Everyone Loves Math is my website. Look, I even made a t-shirt for my website. Boom, baby. So everyonelovesmath.com. Head there. You have a couple of links. One of them is to the live show that you happen to be watching right now. So congratulations, you're already in the right spot. I also have links. I'm just going to show you over here. I've got tutoring links. So if you click on the tutoring link, you'll be able to open up a new window to book a session with me. My availability for the next 2 months is up. Book a session, let's make it happen. There's a link to the message boards, the Everyone Loves Math message boards, where you can join as either a free member or an ELM supporter for $5 a month. Join the Everyone Loves Math message boards, and it's a great way to support me, but also if you're a student, you put your questions up in the Everyone Loves Math like VIP ELM supporter message board, and that's a way to guarantee that your question is going to get solved on our show tonight. All right. So in review, let's go and review again. I'm going to go back up here. So everyonelovesmath.com. You got an about page if you would like to download a picture of me. It's right there. We talk about the tutoring, we talk about the message boards, and then if you, dude, I'm not even going to try to get you to buy merch, okay? This is really just for, for family right now. But if you want to be part of the Everyone Loves Math family, there's a link for merch as well. Because this is my job now. You know what I'm saying? All right. So before we get to the math, there is something that I wanted to address. I've made a purchase, and I am a little, I don't want to say insecure, I'm a little shy about my purchase. And because of that, I'm actually not using it right now. So I want to show you this, okay? I bought one of these. You know these things with the mic arms? Because I want to look like a Twitcher. I want to do they call them Twitchers? I don't even know. But look, I can do this, right? And I can put this in here, but this is just a big honking microphone. And if I do this, I can like completely block my face. So one of the things that I'm going to play with is how in the world, don't worry, you're not going to watch me do this for an hour. But now that I have this new fancy microphone, like, does this look cool? Like, does this look good? Did I mess up? Let me know, because I don't know, I'm not used to having this thing in my face, so it's going to take a little bit of getting used to. All right, just know that. Just know that I have the microphone. I'm a little self-conscious about it. All right, I'm going to move it out of the way, and it's weird. I spent money on it, and I'm actually not using it today. You're right, Stucky. It does look cool, but what do you do with it? I don't know. It's like construction machinery here in my office. So we'll see. But be gentle when you see me next time, because I'll be trying the mic arm. All right. So let's talk about what our show is tonight. So here's the story. I would love to fill up this live show answering your questions. That would be the coolest. If you ask questions, and look, I even got the scroll down there. I got the Everyone Loves Math hotline, where look, there's the number right there. So that Everyone Loves Math hotline, you can call and leave a message. You can text a question. You can take a picture of a problem that you're struggling with, you could take a video of yourself explaining something or asking a question and send it in. And I check them all before the show. So before the show, I check the Everyone Loves Math hotline, and I check the Everyone Loves Math message boards. And then during the show, if you want to ask a question in the Twitch chat, ask it, and I'll stop. What I have this evening is I queued up, I don't know, my normal batch of about 10 questions. And so we're going to go over 10 questions. These were all on the Reddit homework help. Somebody needed help with these, and if somebody needs it, y'all know how this works. That probably means like thousands of people need this help. So we're gonna crack through these problems, but at any time, if you want to interrupt me, and we'll do it. And we're gonna get to it. Let's go. All right. So I wanted to start with a little. Ooh, hang on. There we go. I wanted to start with a little amuse-bouche, a little math squats warm up, and this is a question that we see all the time in geometry. And the crazy thing is, and I haven't done that many geometry problems. I wanted to do a geometry problem that I know a lot of people get wrong, and so we're gonna follow this the best we can. Okay. All right. So for this problem, it says assume each pair of figures below is similar. So we're assuming similarity. And the other thing for this first question, I think we also have to kind of assume that the picture is to scale. It says complete each similarity statement to illustrate which parts of each shape correspond. Remember, the letter order is important. Yeah, not only is letter order important, letter order is everything. So they shouldn't even have said important. That's kind of underselling it a little. If you get the letters in the wrong order, you're all the way wrong. All right, so here we go. The big thing in here is finding the corresponding parts. So just to be really clear about corresponding parts are parts that do the same thing in different shapes. They play the same role in different shapes. And I'm going to show you an example of that by looking at polygon ABCD right here. All right, so what we want to do is we want to match polygon ABCD with these letters, right? E, L, O, and V. And a lot of times they try to be cute. They try to be cute to catch you, because if you see the words E, L, O, and V, do you start thinking about the word love? You know, and you're like, ooh, love makes a word, so let's put that in there. Don't do that. All right, so let me show you how we're doing it. So ABCD is the polygon that they want us to match. So I'm going to start with A. And I am going to put a little circle around A. And we don't always have to do this, but I think it's really helpful. All right, so what is the letter L, O, V, or E that's playing the role that A is playing, except in the left polygon? Well, it's E. Look at A and E. This is imprecise, and we're assuming that the picture is to scale. But if I wanted to, like, you know, I'm not into making things sound harder than they are. A is like the pointy piece. A is like the pointy corner, the super pointy corner. E is the super pointy corner. So guess what? A and E, they correspond. So I know that when they name that polygon ABCD, I know that that A is the pointy one, that's E. So now we just got to see, all right, where do we go from here? So the next place we go is B, and so we go like we go in this direction from A to B. Hey, Stucky, I'm reading it. Stucky, you and I'd love to talk to you later. That direction from A to B is kind of like that diagonal side. That's going to be the same as E to V. So the next letter in order is V, because V is playing the same role in the left polygon that B is playing in the right polygon. Okay, so now let's see. As we continue to kind of go around this polygon, let's see, we talked about A, B, C, D. So there's A. Now B to C. We're going to keep going from A to B to C. So that must be this direction here to O. Again, the corresponding means we're doing the same thing, just in a different polygon. So O and C are playing the same roles in their respective polygons. Whatever O is doing on the left thing, C is doing on the right thing, and then the only other letter left is L. Boom. So even though love would have been cute, it would have been pretty, don't do that. We have to, I mean, the order of the letters is absolutely everything. All right, so I think just for kicks, we're going to do part B, and then we're probably going to move on. Let's do it. So for part B, they did make a cute word. See, they made the word right. Okay. Don't get hung up on the words. That's how they try to get you. That's how they try to get you. So I'm not even going to look at those letters and see what kind of word they think I might be able to make out of it. Don't fall for it. What instead we're going to focus on is the corresponding parts. So what does that mean? Well, here's R. We got to kind of think about, all right, who over here on the right polygon is playing the same role that R is playing. So we got to think about, like, how would we describe R without using the letters I, G, H, and T, because the polygon on the right doesn't have those. So how do we describe R right there? So here's what we can say, and this is what it takes to get this problem right. We can say, well, here's R. R is adjacent to the side with one notch. And R is also, or it's a vertex of the side with one notch. And it's the vertex of the side with no notch. So it's where one notch and no notch meet. Let's see if we can do that. So here we go. One notch, that's right here, and no notch. Where one notch and no notch meet. So I'm looking at this and I'm thinking that E and R are corresponding parts. Those are corresponding parts of their little polygons. The other thing you can think about is you can take that polygon on the right and just kind of rotate it like a quarter turn, and they would basically line up. That's the point. All right, so what do we know? We know that this polygon, whatever its name is, it starts with an E. All right, so now we're just going to do that same kind of crawl around the polygon. The next letter in right is I, and we get from R to I by going across the side with the one notch. Well, the side with one notch, we must go from E to S. So that tells me that the next letter in this polygon is an S. Again, don't get cute. Don't get cute and try to make a word. No getting cute. Cute not allowed. All right, so what happens next? Once we're here, we're probably going to be all right, because look at this. R-I and then G-H-T, all in a row. G-H-T. So what do we got? We got E to S and then L-A-F, all in a row. So I'm going to save myself a little time, and I'm going to go L-A-F. Okay? There's no calculation here, nothing to do other than to look and see which are the corresponding parts. And believe you me, the students that struggle in geometry really struggle with identifying corresponding parts. But we're just looking for the two parts playing the same role in a different polygon or a different shape. All right, next up, let's do it. So we're going to switch to like some Algebra 2, pre-calc. This is a question that somebody asked on the homework help, and the formatting got a little funky, but they asked about 16x to the fourth minus 625 equals 0. And they wanted to solve this thing. Now, here's the deal. I'm actually working on a series of YouTube videos for quadratics and factoring. And in that series, I'm going to talk for kind of a while. Like, we got to do kind of some math to build up here. And so what we're going to do right now is we're going to kind of skip some of that build up to just show that this happens to be a problem that shows off a pattern that shows up over and over and over again. So in order to solve this, you need to know about the difference of two squares. So this is something that, like, if you're in Algebra 1, you should like learn and practice. If you're in Algebra 2 or higher, you should start to like look for this pattern, because this pattern shows up like everywhere. So what is the difference of two squares pattern? So it's the pattern that says a squared minus b squared can be written as a plus b times a minus b. All right. Now, here is kind of my beef with this. This is not like a something that like had to be invented. It's not like we declared a squared minus b squared is the same as a plus b times a minus b. They are the same. Like if you take the right side and multiply it out, you will get the left side. All right. So how do I know I'm looking at a difference of two squares? Well, I know that because 16x to the fourth and 625, those are both kind of on my mental list of perfect squares. And to be honest, whenever I see like two things subtracting, I'm like, is that a difference of two squares? Let's see. So 16x to the fourth, that can be written as a perfect square. It is actually 4x squared times itself. 4x squared squared. Okay, 625 is also a perfect square. It happens to be 25 squared. 25 times 25 is 625. So what I just did is I just showed that even though this thing is super ugly, there it is, look how ugly it is, it's a fourth degree polynomial, we can rewrite it as a difference of two squares. And if we can rewrite it as a difference of two squares, then we can use that shortcut. What shortcut? That a squared minus b squared is going to be a plus b times a minus b. All right, so what I just did there is I set up, I like to call this skeleton of where we're going. We need a plus b and an a minus b. Well, the a's and the b's pretty easy because they're right inside the parentheses. A is 4x squared, so that's going to go where the a's go, and b is 25. So that's going to go where the b's go. Look at us. Look at us. Okay, so we're still solving. By the way, before we go too much on, this is a fourth degree polynomial. It's x to the fourth. So one of the things that you should know when you start to solve is you should be looking for four answers. A fourth degree polynomial should have a fourth degree equation should have four solutions. Some of them might be repeated. Let's see what's up. All right, so looking at this, here's what's crazy, man. That second factor right here, look at this thing right here. Look at that second factor, 4x squared minus 25. Y'all are never gonna guess this. That's a difference of two squares. Yo, man, we heard you like difference of two squares, so we put difference of two squares inside of your difference of two squares. Okay, so the first factor, the first thing being multiplied, is not a difference of two squares. It's just 4x squared plus 25. That's a sum of two squares. And again, speaking to my Algebra 2 students or higher, you should know that doesn't factor. But the second factor does factor more. And because we just did this difference of two squares, I'm going to do this in my head a little bit. We know it's going to be a plus b, a minus b pattern. Let's see. What squares to 4x squared? That's going to be 2x. 2x times 2x is 4x squared. What squares to make 25? That's 5. So if we were looking to factor this completely over the reals, this is it factored. But remember, they want us to find the zeros. So where we are right now, we can actually find two of the four zeros if we just finish this factoring problem. So looking at this problem, we now have things multiplying to make 0. So that means one of these things has to be 0. So 4x squared plus 25, we're going to set that equal to 0. Maybe that's 0. I don't know. Maybe it is. 2x plus 5, that could be 0. And 2x minus 5, that could be 0. And now it's just on us to work these down, get ourselves some answers. I'm going to do this in a different order because I know that I'm looking at a couple of two-step equations. So look at this middle one, right? If I just minus 5 on both sides and then divide by 2, look at us. Then we're done. We get x equals negative 5 halves. All right. Well, why did I say we're done? We're 1/4 of the way done, right? Remember, this is a fourth degree polynomial. So there are four answers. We just found one. All right, this one should give us the second one. If we add 5 to both sides, boom, 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 then we end up with 2x equals 5. This feels familiar because it's really what we just did, except there's no negative. How about x equals 5 halves? That's the second. Remember, 4 answers, that's the second one. So we have 2 more solutions to find, and they come from this bad boy. And here's what I'm going to tell you. Remember, this is, I kind of said this like just kind of randomly and moved on. This is a sum of 2 squares. It looks a lot like the difference of 2 squares that we just dealt with, right? The 4x squared minus 25, difference of 2 squares, right? Difference of 2 squares, sum of 2 squares. Sum of 2 squares does not factor. So lucky for us, this is still, I mean, it's not a 2-step equation, but it's pretty close. Let's try to solve this the only way we know how. Minus 25 on both sides. Okay, so we would end up with 4x squared equals negative 25. Then we'll divide both sides by 4. And we'll end up with x squared equals negative 25 fourths. And then, again, if we're trying to get x by itself, we got to undo squaring by square rooting, so we're going to square root both sides. But this is where there's just all this memorization in here. So I'm going to talk about this, and then we'll come back to it. Because that's really what should probably be on your paper next. So here's the thing, y'all. We square rooted both sides. So let's go back over this. When I had x squared, square root of x squared is x. Because squaring and square rooting basically undo each other. But if I square root the left side, I have to square root the right side. And when I square root the right side, I just put that ugly fraction under the square root. But then I also wrote a plus or minus. Whenever you take a square root, you write a plus or minus. If I ask you about, like, what numbers square to make 9, it's plus or minus 3. 3 and negative 3. So whenever you take a square root, you put a plus or minus. Now, as if to make this, like, even more fun, we got a negative under the square root. So that means we're going to be having like imaginary, complex kind of numbers. That's what that means, man. Welcome to Algebra 2. Welcome to pre-calc and further. So what are we going to say? X equals. So here's what we got to do. I'm going to put the plus or minus. I'm going to take out the I, right? Because if there's a negative under a square root, that's really the square root of negative 1. That's I. And then, oh my goodness, look what I'm left with. The square root of 25 fourths. So yeah, I got so worried about that minus sign, I didn't realize I get to square root 25 fourths. Guess what? 25 is a perfect square. I can square root that. 4, that's a perfect square. I can square root that. So we get x equals plus or minus I times 5 over 2. Square root of 25 is 5. Square root of 4 is 2. So we can say I times the square root of 2, or I times 5 halves. No one writes that. Nobody writes that. We would say plus or minus 5 halves I. That's probably how people say it. And guess what? Those are the other 2 answers. So if I were to just go and put the answers to this problem, I would say x could be, well, let's look. Up here, 5 halves, remember these answers. 5 halves are negative 5 halves. So I could write them out, or I could just be cute and say plus or minus 5 halves. Because those are, positive 5 halves and negative 5 halves. And then plus or minus 5 halves I. There's all 4 of the answers. Right? Positive 5 halves, negative 5 halves. Positive 5 halves I, negative 5 halves I. All 4 answers for that 4th degree polynomial. Right? Right? So fun. You love it. You love it. I know what you're saying. You're saying, Joey, could we do some like beginning calculus? What if we did some beginning calculus? I'm totally going to do it. And I know what else you're saying. You're saying, Joey, could you please make the text so incredibly small that no one could possibly read this? So I'm working on the text part. I'm working on it. I tried to make it bigger. I think I'm going to end up retyping this. So that's all right. We can do it together. No problem. So we're talking about the deck of a bridge. So I'll read this to you. It says, the deck of a bridge is suspended 205 feet above a river. If a pebble falls off the side of the bridge, the height in feet of the pebble above the water after t seconds is given by this formula. So we have this formula, y equals 205 minus 16t squared. And y gives us, let's take a look. Y gives us the height, so I'm just going to make a couple little notes. So y gives us the height of the pebble, H-I-G-H-T, and t gives us the number of seconds. And by the way, just to make sure that they don't try to trick me, I'm going to say it's the height in feet. Man, because you never know those word problems. If they give you the height, all of a sudden the height's in inches, and you know how that goes. Okay, so there's the formula for the height of a pebble after t seconds. Then it asks for the average velocity in feet per second of the pebble for the time period beginning when t equals 3 and then lasting for 0.1 seconds. All right, so I'm going to rephrase what they want. What they want is they want the average, red ink, we got to get pretty. How about that? The average feet per second, the average velocity. And then it says from 3 seconds to, and then they want 0.1 seconds to elapse. So that would be 3.1 seconds. So we're going to look at the average velocity between those two times. Now, before we move on, that's a very small point of time, right? Like timing someone from how far are they from 3 seconds to how far they are to 3.1 seconds. That's a really tiny piece, but if we're careful and we do the math right, we're going to be able to come up with the velocity, no problem. Okay, so now we want the velocity. So here's the formula that we have to have. Did they call this f of x or anything? No, they called it y. Okay, so here's the thing. When we're dealing with position, with distance, and we want velocity, we know that velocity is like the slope of distance. They're asking us, this is a slope problem. So whenever they ask about the average velocity, that's in pre-calc or in calculus, that's a slope problem. And yeah, you better believe the slope problem is, when I say slope, I'm talking like Algebra 1 slope. Like that definition. All right, except we just have to convert it to our problem. So let's talk about our problem. So our problem doesn't have x's, it has t's, and so we're cleaning stuff up. All right, I set the table. Like now we're gonna take care of it. Okay, so here's what we're gonna do. Instead of these x's, so the y's were right because the equation has a y in it, but instead of these x's, we need to put t's in here because t is the input variable. So I'm going to start with the denominator because it's easier. And I know that because I've done this before. So what they want us to do, if we're doing the slope and we're subtracting these times, is they want the second time minus the first time. So let's go back up here. Here are the two times. Let's do the later time minus the earlier time. 3.1 minus 3. So we have the times down at the bottom. Now what we need in the numerator are the y's subtracted. We know we have a subtraction problem to do, but we need the y's. And here's where we got to do a little bit of work because the y's are what we get when we plug 3 and 3.1 into that original equation. Remember, we have this equation up here. So we're going to plug 3 and we're going to plug 3.1. We're going to plug them both in there. And let's see what we get. So let's see, let's start with y1. So y1 is what happens when we plug t1, the 3 seconds in there. So let's see, I've already forgotten what the equation is. 205 minus 16t squared. So this would be 205 minus 16 times 3 squared. Okay, and then y2, that's going to be the y if we plug in the later time. So we're going to do 205 minus 16 times 3.1 squared. Because that would be the output that goes with 3.1. All right, so now it's time to do a little calculating. Let's see. I'm gonna just write these down. I'm gonna write it on my scratch paper, and then we're gonna go to my favorite calculator. You can probably guess what it is, right? I bet you know. I bet you know what my favorite calculator is. How about this? Let's go and boop boop. Desmos, baby. Desmos. My favorite legal website. It's the best. All right. So even though Desmos is a graphing calculator, don't forget the second word is calculator. So even though I don't care about a graph, I'm going to put 205 minus 16 times 3 squared. Boom. So that comes out to 61. Can you all see that? It's real tiny. That's a 61. All right. And then I'm going to go down because I'll just go down to the next line here. And I'm going to do 205 minus 16 times 3.1 squared. Okay. And let's see. I'm going to make sure I did... I don't like how that formatting looks. So the nice thing about Desmos is you can make the formatting look exactly like your paper. Okay? All right. So what do we have? We have that at 3 seconds, the pebble is 61 feet above the ground. And at 3.1 seconds, it's 51.24 feet above the ground. Okay. Let's go back to the whiteboard and work some stuff out, shall we? All right, so here we are. What did we figure out? We figured out that this is 61. Wait, this is 61. And this one is 51.24. And so now what we're going to do is we're going to stick these numbers. Remember, these numbers are our numerators, or are the two things being subtracted in the numerator. So what are we looking at? Well, make sure that your inputs and outputs line up. So there's a 3.1. Remember that was the input 3.1. So the output was 51.24. I want those to line up. I want the 51.24 to be over the 3.1 because that's the y that goes with 3.1. 61 was the y that goes with 3. So I line those up. And now, guess what, y'all? Going back to Desmos. I'm going back to Desmos. I love Desmos. I love it. I love it so much. Someday you'll love it. I'm kind of thinking, like, if I ever got like a tattoo, would I get like a Desmos tattoo? I don't think I could do it, but like part of me wants to do it. All right. So we're going to do a division problem, and I'm going to put 51.24 minus 61 up in the numerator, and then 3.1 minus 3 in the denominator, and I end up with negative 97.6. All right, let's go back and give our answer. So this fraction comes out to negative 97.6. Now what this is this is the change in distance over the change in time. And another word for saying that is the average velocity. So I would say, if I was going to write my answer like in a sentence, the average velocity of the pebble from 3 seconds to 3.1 seconds is negative 97, what was it, 0.6? Was it 0.6? Yeah, negative 97.6, and that's feet per second. All right, so again, if you want to find the average velocity is the slope of the distance graph. All right. We doing good? We having a good time? How is everybody out there? For those of you that just joining, if you have a math question, pop it in the Twitch chat. I can stop doing these problems at any time and take a question that anyone has, man. It's all good, okay? Happy to help. Speaking of help, let's do another problem. Why not? Let's do another problem. All right. Oh, yeah, this one. This was a follow-up to that previous one. So here's why you're doing all those little tiny, like 0.1 seconds in the subtraction and stuff. So let me read this out to you. a rock is thrown upward on the planet Mars with a velocity of 8 meters per second. See, that's where we'd be careful because now it's meters. Its height in meters, t seconds later, is given by this equation. This time they give us y equals 8t minus 1.86 t squared. So that's the equation. Looks pretty familiar. Looks kind of like where we were in the last problem. So the person that asked this question did part A. So it said find the average velocity over the given time intervals. And so if you look between 1 and 2 seconds, all right, I'm holding my hands here so you know something's happening. Between 1 and 2 seconds, the average velocity was 2.42 meters per second. Between 1 and 1.5 seconds, the average velocity is 3.35 meters per second. Now we're going to get from 1 to 1.1 seconds, the average velocity is 4.094. From 1 to 1.01 seconds, so we're talking about a really tiny sliver, really close to finding what is actually happening at 1. So if we approximate with 0.01, we get 4.26 and some garbage. And then if we approximate with 1.001, we get like 4.27 and some garbage. Now, I'm saying all this because of where they're going in this problem. So now take a look. Part B is the one that this person got wrong. So part B says, use your answers from part A to estimate the instantaneous velocity. What's happening exactly when t equals 1. So we're crawling up on getting t equal to 1. We started with like this distance, and we went to half, then 0.1, 0.01, 0.01, and look how the numbers changed. So the first velocity, like for the widest interval, was 2.42 meters per second. Then it went 3 point something, 4.094, 4.2614, 4.278. It's getting really close to something. I hopefully, because this is like an online kind of problem, hopefully they accept a couple of different right answers. The answer's got to be really close to this. It's got to be really close to 4.278, because now we're talking about like, yo, we're getting up to 0.001. So I bet the answer, if it's not 4, it's something really close to this, a little bit bigger, because each time the answer's getting bigger. So I might say 4.28, or maybe it's 4.29. It's something really close to 4.27814. Okay? Okay, well, I said okay. You can't, I mean, you could type okay in the chat, but then it would be too late. I'd move on anyway. Okay, so, let's switch things up. It's been a little pre-calc-y. I like a little pre-calc, a little algebra 2, a little geometry. Why not? And this problem caught my attention. So we're saying mark the following angles on a unit circle and give the coordinates of the point determined by each angle. Ooh, I love it. Unit circle. Every math teacher has this thing for the unit circle, and every kid hates it. So let me give you my honest answer. I don't really like the unit circle. I like degrees a lot. And so most of the time, whenever I'm working with the unit circle, I kind of secretly do degrees off to the side. But we don't even have to do that here. Here they're straight up giving us degrees, so whatever. All right, so they want to know, we're just going to do letter A. They're like, all right, what's up with 100 degrees? So what's it want? It wants us to mark 100 degrees on a unit circle, and then it wants us to give the points of the coordinates, or give the coordinates of the point determined by that angle. Okay, so the unit circle, again, if I'm helping you, you already know. Unit circle is a little circle. It's got a radius of 1. It's right there in the middle of every graph, and it helps us. It helps us with trigonometry. All right. If you want to know more about it, book some tutoring time, because I'm not going to spend 3 hours talking about a unit circle right now. Okay, so let's talk about 100 degrees. Where is it? Well, now you got to start thinking, right? So 100 degrees is an easy one, but 90 degrees, that's an easy one, right? 90 degrees. So let's look at that. I'm going to be like, all right, here's our graph. Okay. I'm going to figure out, I don't know if I need more or less caffeine to make these lines straight, but we're going to see. So 90 degrees, let's do this in like green, would be like straight up and down. So we always start at 0 degrees. 90 degrees would be right up there, that's straight up and down. So 100 degrees is going to be like a little bit further than that. It's going to be like 10 more degrees, right? That's going to be 100 degrees. Okay, so let's clean this up. I'm going to clean this up because I don't like how this looks. All right, so we're going to take that out because we're not talking about just a 90 degree. We're talking about this whole thing, which is 110 degrees. Okay, so far so good. Now, we just graphed it. Now, by the way, they want it on the unit circle. So the unit circle, I could draw the circle around the origin, but here's really what I'm going to do. I'm going to be like, or I could zoom in. Why don't we zoom in? That would be really cool. I mean, it would be, the math version of something really cool. So, okay. So we only really need the top half of this graph, right? And I'm going to go and make a different line. Am I just redoing the exact same thing? All right, so here we go. We're going to put a dot here. We're going to call this 110 degrees. Or, wait, was it 100 degrees, wasn't it? Y'all didn't even correct me. It's 100 degrees. I don't know why I'm yelling at chat. I'll never yell at you again. I'm sorry. Let's be friends. All right, so we got 100 degrees. And then this point here, because this is the point that they're talking about on that unit circle, we only know one more thing about this whole picture. Because this is the unit circle, the distance is 1 from the origin. That's a distance of 1. All right, so for part A, we got the answer. We drew a 100-degree angle, and we labeled what we knew, which was this point that they're looking for. And remember, in this problem, the part B, they're looking for the coordinates of this point, like the x comma y. We'll get there. But right now, we know we got a 100-degree angle, and it's 1 unit away from the origin. All right, so now it's time to figure out those coordinates. And there are all kinds of slick ways of doing this. I'm going to do it the way that I like because I'm the one holding the marker. All right, you hold the marker. Okay, and what we're going to do is I'm going to draw us a little triangle. See, that looked a lot better. Look at me. I guess I can draw down, but not I don't know. Whatever. Okay. So next up, the reason why I draw a triangle is because listen, if they're talking about the unit circle and they're giving us degrees and stuff, trigonometry's coming, man. You know trigonometry's coming. And if trigonometry's coming, then I need a right triangle because that's where trigonometry lives. That's its house, man. Okay. So here's my little right triangle. I'm going to label x and y because that's what I want. I want to know what is x and what is y. So we're getting there. One more thing to label. There's one more thing we know about this problem. And specifically about that right triangle. And the thing that we know about this right triangle, I guess I'll do it in green. This angle down there must, oh, it's hard to write small, y'all. It's hard to write small. This angle right there, that angle must be 80 degrees. How do I know that's 80 degrees? Because if you combine it with 100, you get a straight line, 180 degrees. You know what I mean? All right. So all of that information combined, we're going to be able to figure out the coordinates x and y. All right, so what are we going to do? Well, if we look at this thing, if we look at this thing, what are we going to say? Well, we can come up with our SOHCAHTOA business. That's what I would do. I would say something like, let's find x. So x, I'm going to use the sides x, because I want to know what x is. I'm going to use 1, because I don't want to use a variable. That'll make the equation more complicated. So I'm going to use this side and talk about the 80 degrees. So if this is the angle we're talking about, that 80-degree angle, then x is going to be the adjacent. 1 is going to be the hypotenuse. We're talking about cosine. All right, the other piece is well, let me write it out first. So what do we know? The cosine of 80 degrees is like x over 1. Because the cosine is adjacent over hypotenuse, so x is adjacent, 1 is the hypotenuse. And if we look at this, we know that x, that means x is the cosine of 80. And if we wanted to, we could switch over to Desmos and pop in the cosine of 80 to figure out what that is. But I also know that's like some ugly decimal. And the cosine of 80, that looks prettier than that ugly decimal. I'm going to leave it. How about we do an equation with y? So we're going to use y and 1 in this angle. So let's see, we know 1 is the hypotenuse, y is opposite of the angle, and opposite and hypotenuse, that is the sine. So we can say that the sine of 80 degrees equals y over 1. Or, since dividing by 1 is like a total waste of time, y is just the sine of 80 degrees. And doing all that, oh, by the way, I should mention something. I should mention something before I move on, because I've lied a little bit here. I've lied a little bit. So, so if we were to put these numbers in, by the way, we could say, let me think here. So we could say our answer could be the cosine of 80, because that's x, comma, the sine of 80, because that's y. And if we put that, we will have done a lot of good work. We've done a lot of good work, but we'd get this problem wrong. Yeah. So, because there is one change we need to make. I guess maybe we do need Desmos. Let's look in Desmos for a second. Let's go boop, 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 boop. So the reason why I'm going to go in Desmos is I want to look up and see what the cosine of 80 is. So cosine of 80, let's see. Ooh, that does give us does that give us a negative number? Sure enough, it does. I want to check that. I want to check that the cosine of 80 gives us a negative number because, oh, I need to be in degrees, don't I? That's why. So the cosine of 80, I need to fix my fix Desmos so we're in degrees. Are we in degrees? Let's see. Boop, boop, boop. Oh, now I forget how to go to degrees in Desmos. Where do we go? Graph settings. Haha. So, oh, here we go. Degrees. So now we're in degrees. And if I type in the cosine of 80, oh, that was a long walk. The cosine of 80 is, if you look at it, it comes out as a tiny little positive number. And if we go back and look at our picture, we know in this problem x needs to be negative because look at where x is. X is to the left of 0 on the axis. So we need to say it's the opposite of the cosine of 80. We need to make sure that the x is negative there. All right. All right, good times. Good times, USA. Let's see. Where are we at? I don't even know where we're at. See, I get lost in the math, man. I just get lost in the math. Okay, so let's see. This is going to be, let's see. I think this will probably end up being the last, maybe the last question. I think maybe we'll do 2 more. So let's tackle this. So this person was asking, this is an 8th grade question. They were asking about 5, what is this? 5 to the 6th times 5. That was the question that they were asking about. And I wanted to put this on here because this is one of those things where, oops, you should be able to see it. So here's the thing, y'all. We know, you know this, you know that there's some shortcuts and stuff that you can use when you deal with multiplying and exponents. There are these shortcuts here and there that you can work with. I hate most of the shortcuts. And the student that's asking a question about this should not be doing a shortcut because you should be doing the real way. And really, the way that you get to a shortcut is by doing the real way over and over and over again, doing your math squats, getting your math reps in. All right, so instead, what are we going to do here? We're just going to make this, we're not going to make this more complicated than it is. 5 to the 6 times 5. That's really what they're asking us to simplify. So if you get yourself twisted around, always fall back on what does exponent mean. 5 to the 6th power means you write 5 6 times and multiply it together. That's what 5 to the 6th power means. Boom, look at me. I'm 5 to the 6th power right there. So if we're going to do 5 to the 6th power times 5, then I'm just going to tack on another times 5. All right, so don't reach for a calculator because nobody needs you to do that. What they want us to do whenever we're dealing with exponents is to write this in like a simplified cool kids way. So here's the thing, man. If I multiply 5 by itself 6 times and then multiply by 5 again, haven't I multiplied 5 by itself 7 times? You know what I'm saying? We did 6 times. 1, 2, 3, 4, 5, 6. And then we did that other times 5. So the answer to this problem is just 5 to the 7th power. All right. And, you know, if we really wanted to, we could say, okay, 5, oh, remember up here, 5 is the same as 5 to the 1st power. And then somewhere in the back of your head, you probably remember that you're allowed to add 6 and 1 to get 7 and get your answer. Seriously, why do you need a shortcut for something that takes 15 seconds? Just do it the real way. It builds character. It makes you a stronger student, I promise. All right, last problem of the night. I haven't done a volume one yet, so I figured we'd bust out the volume. And if you want to see more volume, let me know. I'll tell you after this problem how you can let me know. So this one is, what is the volume in cubic yards of the cylinder? Round to the nearest tenth, and I checked. Everything in this problem is already in yards. And I had to check that because I know they tried to trick us. Okay, so in order to do this, you need to know the formula for the area of a cylinder. I'm sorry, the volume of a cylinder. So I'm really bad at remembering the volume of a cylinder, but I do remember that the volume of the cylinder is base times height, and the base is a circle, and circle is pi r squared. So it's the circle, that's the base, times the height. How about that? Base times height. So in this problem, if they ask us, oh, and there are, you know, besides base times height, there's really not any other slick ways to remember that. If you were doing this in your class, I would definitely ask my teacher, are you going to give me the formula on the test, or do we need to study? And if the answer is you need to study, then have that written on a card, do your reps, do your math squats. All right, but for us, we are, if we know the volume formula, then it's just a matter of plugging some stuff in. So pi, we know is pi. There's a button on our calculator for it. In this problem, I know it's hard to tell because it's tiny, but the radius is 6. So we're going to say times 6 squared. And then the height is 11. All right, so if we multiply this out, we'll have it. And by the way, the answer will be in cubic yards. All right, so we can put a yards with a little cube. All right, so we have to multiply this. And this is the reason why I picked this problem, is if you are asked to multiply, go to the calculator, put it all in as one chunk. And hey, guess what? The calculator I'm going to use? Desmos. Did y'all see that coming? When I said put in a calculator, we all like, I bet he's going to use Desmos. And then I totally said Desmos, and then you felt vindicated. All right, I know how it works. I know how it works. Did you just give yourself a high five? Because you're like, I bet he's going to use Desmos. All right, so let's stick all this in here. Here's the really neat thing. In Desmos knows what pi is. You can even just type it in, pi, and it turns into the little pi. How about that? All right, so now we're going to multiply it by 6 squared. All right, oh, and it put these parentheses that make it look weird. I want it to look the way I want it to look. 6 squared, and then times 11. So when people get this problem wrong, I bet you, and this breaks my heart, man, people will get this problem wrong because they'll put it into their calculator like a little piece at a time, and they'll like do the little calculation round, do another little calculation and round. And at the end, you don't even know how close your answer is. For us, we know that this is now a really good answer. What's it? 12,706, blah, 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 blah. I'm going to write it down so that I can go and give this answer. All right, 1244.070698082, and probably the calculator gave up after that, right? You know how that works. All right, so let's go back to the whiteboard and answer this question. So what do we got? Well, they ask us to round to the nearest tenth. So I'm going to put this down here, because the tricky part of this problem is not the formula. It's about really just making sure you don't do something silly to get the problem wrong. All right, so there's what came out of our calculator. We want it to the nearest tenth. So the tenths place is this 0. Okay, so let's see. We either keep the 0 or we round up. Well, look to the number to the right of it. It's a 7. That means we're going to round up. So the 0 turns into a 1. Round it up. So the answer is going to be 1,244.1 cubic yards. How about that? All right, so I do have a couple more questions, but we're going to tackle those in our live show tomorrow. Let's talk just for a minute, make sure everybody knows what's up. We're going to talk about the Everyone Loves Math website. So everyonelovesmath.com. Anybody that needs extra help, come to this website. You love it. On this website, you can learn more about me if that's where you're at. You can sign up for tutoring. So I have a link here for tutoring. And if you click on the tutoring, it'll open up my calendar. You can put a spot on my calendar, and I show up. We got it. We also have the Everyone Loves Math message board. So if you want to ask questions in between the shows, or if you want to ask a question to be on the show, you can sign up to be on the Everyone Loves Math message boards. There is a free option, and there's a paid option. And right now, the only difference is the paid option, you get kind of a little VIP section to ask questions, and you're supporting me. So I anticipate that a lot of the people that pay $5 a month are people that just want to support what we're doing here. Okay? And then finally, don't buy my merch yet. All right, but I got merch. What kind of a weirdo does merch? And I've had a Twitch stream for like 10 minutes. A weirdo that has a few minutes on his hands. All right. So, all having been said, we're like done for the night, man. We're gonna call it a day. I will see you back here tomorrow if you do so choose. I will see you at, what is that, 9 o'clock, and we'll go from 9 to 10. Ask your questions through the Everyone Loves Math hotline down there. Yeah, good game to you too, Stucky. Y'all stay classy, and we'll see you later.